Welcome. We've all been there. A critical system is down, alarms are blaring, and the first question is, where is the runbook? Too often, the answer is a frantic search for a document that is outdated, inaccurate, or buried in a forgotten wiki space. This traditional approach to incident response documentation is fundamentally broken. It treats runbooks as static artifacts in a dynamic world. Today, we're going to do a deep dive into a more resilient paradigm, automating the generation and maintenance of runbooks, transforming them from a liability into a dynamic, reliable asset for your major incident protocols.
Manual runbooks are a trap for well-intentioned teams. Their primary failure mode is staleness. The moment a developer pushes a change, a new environment variable, a different API endpoint, a modified security group rule, the manually written runbook begins to drift from reality. This is configuration drift, and during an incident, it can be downright dangerous, leading engineers down the wrong path. Second is the immense cognitive load. When you're under extreme pressure, your ability to parse dense paragraphs of text plummets. A good runbook should reduce stress, not add to it. Finally, there's the issue of versioning and discovery. Wasting 5 minutes determining if you're looking at the latest version from 6 months ago or the one from yesterday is 5 minutes you don't have. Each of these failures directly and negatively impacts your mean time to resolution, or MTTR, the metric that matters most when everything is on fire.
So, how do we fix this? We treat runbooks like software. We build a pipeline. The foundation of this approach is establishing a single source of truth. This isn't a wiki, it's your actual system configuration. Your infrastructure is code files from Terraform or Ansible, or even live data queried from cloud provider APIs. The first step in the pipeline is an automated script that parses this source of truth. It extracts the critical metadata, service dependencies, IP addresses, health check endpoints, and alert definitions. Next, this structured data is fed into a template engine, like Jinja2. Here, you define a standardized runbook template with placeholders for all the dynamic data. This ensures every runbook for every service has a consistent, predictable, and easy-to-read structure. The final step is publishing. Instead of a PDF, the pipeline commits a markdown file to a Git repository, updates a page via a wiki API, or even populates a checklist directly within your incident management tool. This entire process is integrated into your CI/CD pipeline, ensuring that a change to infrastructure automatically results in an updated runbook. Generating a runbook once is not enough. The system must maintain itself. The key is trigger-based updates. Your runbook generation pipeline should not be a manual process. It must be hooked directly into your CI/CD system. A Git push to your main infrastructure branch that passes all tests should automatically trigger a runbook regeneration. This ensures documentation never lags behind production. But how do we ensure the runbook is correct? We introduce automated validation. This means adding a step to your pipeline that tests the very commands within the runbook. For example, a script could curl the health check endpoint listed in the document or test the SSH connection string. If the command fails, the build fails, preventing a broken runbook from ever being published. The final and most critical piece is the post-incident feedback loop. After every major incident, your postmortem must ask, was the automated runbook useful? Any shortcomings are used to create a ticket to improve the template, not the generated output. This way, a lesson learned from one service's incident improves the runbooks for all services. By embracing this runbooks as code philosophy, we fundamentally change their role. They cease to be a static burden, a chore that is always out of date. Instead, they become a dynamic, living asset that is programmatically tied to the reality of your systems. You are no longer just writing documentation. You are engineering a reliable, self-updating knowledge system that directly reduces MTTR and lowers the cognitive load on your engineers during your most critical moments. The path forward is to start small. Pick one essential, high-impact service and build your first automated runbook pipeline. Thank you.